about properties of rational exponents and radicals. And we're trying to simplify the following expression. In this case, we're talking about both rational and radical expressions. And so for the first one here, we have the fifth root of 3 and we have the fifth root of 8. Neither one of these can be simplified any further without manipulating a little bit. And so the issue that we have is we have a radical in the denominator that we want to get rid of. So one thing that we can do is we can rewrite what's in the denominator here, and we can say the numerator is going to stay the same, fifth root of 3, and in the denominator we're going to say the fifth root, and the way that we can rewrite 8 is we can rewrite it as 2 to the third. And now in order to get this radical out of the denominator, remember we have to match, we have to have the same number of sets under the radical that matches the number. So we're looking for 5 of something. In this case, we're looking at 2's. We already have 3. So what we need to do is we need to add 2 more down here. So we're going to multiply by the fifth root of 2 squared over the fifth root of 2 squared. What that's going to do is it's going to give us 2 to the fifth in the denominator, which will cancel that out. So, and again, we're multiplying by this because this is still 1 and we're not changing the value of the expression. So when we go ahead and do this, 3 and then 2 squared is 4. So 4 times 3 is 12. So that's going to be in the numerator. And we still have to have the fifth root in the numerator. And then that's going to be divided by, we have the fifth root of 2 to the third times 2 to the third, 2 to the third times 2 squared. So that is 2 to the fifth, because if we have the same base, we can just add the exponents. And then we have the fifth root and the raised to the power of 5, so those cancel. And so our solution is the fifth root of 12 over 2, and that is in the simplest form. Then we're looking at the next example, and what we have is we have 4 divided by the cube root of 81, and so we can't simplify that down to an exact value, so we want to simplify this radical as best we can. And so we can rewrite this as 4 over the third root, and we know 81, we can break that down to 3 to the fourth. And so we need to have 3. Right now we have 4. So we can actually take 3 of these out of the radical. So we have 4 over 3, and then we still have the third root. We took 3 out, and there was 4 there originally, so we still have 1 3 under the radical. And in order to get rid of the radical in this case, we need to find 3 of what under the radical. Right now we have 1. So what we have to do is we have to multiply by 2 more. So we're going to multiply by the third root of 3 squared. So we have 1, and then we have 2 more. And the third root of 3 squared. Whatever we do in the denominator, we have to do in the numerator. This is a value of 1. So it's not changing the value of the expression. So we go to multiply this out. We get 4 times the third root of 3 squared. 3 squared is 9. So that's exactly what we're going to have in the numerator, is 4 times the third root of 9. And then in the denominator, we have 3. So that's that 3 there. We have 3. And then we have the third root of 3 times the third root of 3 squared, that becomes the third root of 3 cubed. And we know that that cancels out. So we can rewrite this as 4 to the third root of 9 divided by 3 times 3. And so the solution for this one in simplest form ends up being 4 third root of 9, and then 3 times 3 is 9. And then we have the last example here. We have 25 to the 5/9 times 25 to the 7/9. And then we have 5 over 5 to the 4/3. So right now, what we can do is we can rewrite this so that we have all of our bases are the same. That can be our goal. So 25, 25, and 5, they can all be written as base 5. So 25 can be rewritten as 5 squared. And then that's 5 to the 9th, or 5 squared raised to the 5/9 power. And then we can go times 5 squared raised to the 7/9 power, all over 5 raised to the 5 raised to the 4/3 power. We're not quite there, not quite where we want to be, because the denominator is written as 5, but the numerator is written 5 squared. So we got to get rid of that 5 squared. And what we can do is we can multiply these together. Remember, if we have a number and an exponent raised to another exponent, what we can do is we can multiply the exponents together. So another way that we can rewrite this is we can rewrite it as, so we multiply an integer with a fraction. We just multiply the numerator, leave the base. So 5, 2 times 5 is 10, times, and then we have our 5, and then 2 times 7 is 14, and then we leave the base alone. And then in the denominator, we don't do anything with the denominator, but what do we notice about the numerator? We have 9 and 9. So if we're going to want to add these all together later, what we want to do is we want to make that denominator the same. So we can multiply this fraction by 3 here. So 4 times 3 is 12, and 3 times 3 is 9. And now we can rewrite this because we have all the same bases. So the same base joined by multiplication, we add the exponents. Same base joined by division, we subtract the exponents. So we can rewrite this as 5 10 over 9 plus 14 over 9 minus 12 over 9. And in this case, when we say 14 minus 12, that ends up being 2 left over. And then we can say plus 10. So that ends up being 5 to the 12th, 12 over 9. And then we can reduce this fraction. And we can say that that is equal to 5 and 4 over 3. And that's in the simplest form.